All right, so example number 3 here, it says find the surface area of the triangular prism. This is a prism, so we can use our formula for prism, which we said was perimeter times height, and again that's perimeter of the base, plus the 2 base areas, and T for total surface area. Okay, well, first thing we need is a perimeter. In order to find the perimeter, we got to find the perimeter of the base. Remember, the base is the thing that is not a rectangle, so that means this triangle is the base. So let's do it in blue here. Problem is that I have this right triangle. I have this side 9, this side 8. I do not have this side to get the perimeter. However, that shouldn't be that hard to do. So if I just call that C, if it's a right triangle, 9 squared plus 8 squared needs to equal C squared. Well, 9 squared is 81, C squared is 64, and that just equals C squared. 81 plus 64 is 145, so I'm going to go over here. We get C squared equals 145. And if we take the square root of that, we end up with C equaling the square root of 145. Now that is not a perfect square, but it still has a value that we can use. So what's the perimeter of my base, or the perimeter of that triangle? It's 9 plus 8, which is 17, plus the square root of 145. So as I go to plug all this into my formula, first thing I'm going to plug in is the perimeter. And I'm actually just going to write it like this for now. 17 plus the square root of 145. Later I'll plug this into a calculator, I'll get an actual decimal answer, but for now, that's my perimeter. Okay, the height refers to the actual height of the prism. That's this distance up and down. That's the distance basically from one base to the next. And so that's 5. So I'm just going to multiply that by 5. Okay, the next part is plus 2 times the area of the base. Well, again, the base is this triangle, and I want the area of it now. Well, the area of a triangle is just 1/2, and now lowercase b for base times height. Height of the, I know we already talked about the height of the prism, but now we're talking about the height of the base. So 1/2 of 9 times 8. Okay, we can simplify all this in exact terms and then convert it to decimal, and that's what we're going to do. So let's just zoom in here and just do the math now. I can distribute the 17 times 5. 5 times 10 is 50. 5 times 7 is 35, so I get 85. Plus 5 rad 145. Okay, plus, what happens over here? Well, 2 times 1/2, that kind of just cancels each other out. So I don't need to worry about that. And 9 times 8, that's 72. So I have a couple of like terms, 85 and 72. And that adds up to 157 plus 5 square root 145. And again, that would be in units squared. Let's see, what were my units? They didn't give them to me. So I would just do parentheses, units squared. And when I plug that into my calculator, it's approximately 217.21. Again, that's in units squared. So either one of those are potential answers depending on what form they ask it in. Okay, so that was a good demonstration of how you can use the formula for the surface area of a prism. Here's another problem, but one little change on this one. It says Weston wants to have an ottoman reupholstered. Find the surface area that will be reupholstered. Okay, this is just a rectangular prism, so it's the same formula, but there is one slight difference. Think about it. Yes, they're going to reupholster the sides. Yes, they're going to reupholster the top. But are they going to reupholster the bottom? No, they're not. So when you look at this formula, are you still going to need 2 base areas? You shouldn't. So the formula you're going to use for this one is still T equals PH, because that's the sides, plus 1 base area now, because you only need 1 top. You don't need the bottom. So it's thinking like that that's really important, and how to use these formulas critically. All right, I'm going to let you guys try and figure out the rest. And and then you can unpause when you're ready to check your work. All right, so hopefully you saw that your perimeter, the perimeter of the base, is going to be 3 feet plus 2.5 plus 3 plus another 2.5. So these two add up to 5, these two add up to 6, and 5 plus 6 is 11. So your perimeter is 11. The height is 1.5. And then the area of the base, and only the top base, is 2.5 by 3, which is 7.5. So 11 times 1.5 is 16.5. Add those together, and you got 24 square feet. That's how much fabric you're going to need to reupholster this ottoman. All right, let's go on to the next question. An office has a recycling barrel for cans and papers. The barrels are cylindrical. Okay, that's important. That's a key word there that tells you you're going to be using the formula for cylinder. I'm going to write it up here. It's 2 pi RH plus 2 pi r squared, where this is the side and this is the two circular bases. Okay. Each barrel is 3 feet tall. That looks like a height, so let's go ahead and plug that in. 2 pi, I'll plug in the radius in a second. The height is 3, and the diameter is 30. So right away, if the diameter is 30, we should know that the radius is 15. So 15. How many square feet of cardboard is used to make each barrel? Now let's read through this real quickly. I want you to understand something. The barrels are cylindrical with cardboard sides and plastic lids and bases. And the question asks for how much cardboard. So, do we need to include the lids and bases? Do we need to include this part? The answer is no, we don't, because these are made of plastic and they're not asking about how much plastic. They're just asking about the cardboard. So that's just this part. We can actually just forget about this part. We don't need to worry about the top and the bottom because they're just asking about the sides. So, easy enough. 2 times 15 is 30. 30 times 3 is 90. So we have 90 pi. And that's in square feet. Again, they may ask for this rounded to the nearest, maybe let's say 100th. If they do, I just plug 90 times pi into my calculator, and I would get that that's approximately 282.74 square feet. Again, so I'm just showing you how to find both types of answers. Okay, exact form and decimal form. All right, so we got another question that's similar. It says find the surface area of a cylinder with a height of 6.6 and a radius of 8.3. This one just asks for the surface area, so that means we are going to need all the parts, including the sides and the bases. So I'm going to rewrite the formula for you. And what you might have noticed is that there's two forms of this formula. Well, one form, and I think it's sometimes a little bit easier to manage, has some factoring in it. So we could rewrite this if we could take a 2 out of both terms, put a 2 out front. We could take a pi out of both terms, put a pi out front. We could take an r out of both terms, put an r out front. This would leave us with an h and another r. This formula is sometimes a little bit easier to work with when you're finding the total surface area. That's why I give it to you. So you may want to try this one. If you want to use the one on top, it's fine. It doesn't really matter. They both will get you the same thing. Okay. Go ahead and give that a try and then unpause the video when you're ready to check your work. Okay, so all I did is plug it in. I used the bottom one. 2 times pi times the radius times, and I put the radius first, it doesn't really matter, radius plus height. If you work all that out, everything except for the pi, you get 247.34 pi. And so even though there's a decimal here, this is still exact because we didn't round anything. And then if you plug that in your calculator, you can round that to the nearest nearest hundredth, and get 777.04 square feet. Okay, got another one for you. This one says, find the radius of the base of a right cylinder. A right cylinder is just still a cylinder. It's just a cylinder that goes straight up and down. If the surface area is 128 pi square centimeters and the height is 12 centimeters. So we're giving you the height and we're giving you the surface area and we want you to solve for the r. The equation on top is probably a better one for this. And I will tell you that this is a quadratic, it's going to create a quadratic formula. So I'm gonna kind of start it with you guys and I'm going to let you guys finish it. So let's go ahead and plug in what we know. We know that the surface area is 128 pi. And then that's equal to times pi. We do not know the radius, but we do know that the height is 12, plus again 2 pi r squared. And they want us to solve for r. Well, let's just zoom in and do a little bit of math here. First of all, I see that I have a 2 times a 12 here, so I could rewrite this as 128 pi equals 24 pi r plus 2 pi r squared. Okay. First thing I want you to understand, I told you guys this back at the beginning of the year, but we've gone over this a bunch of times. Whenever you have an r squared or an x squared, that's a quadratic equation. And in order to solve these, you need to get the whole equation equal to 0. So I'm going to subtract 128 from both sides, and I will get 0 equals, and I'm going to put the r squared in front. 2 pi r squared plus 24 pi r minus 128 pi. Now, this is pretty gnarly. This is a pretty gnarly equation because you got all these pi's in there, you got these big numbers. However, I remember telling you as well that if you have a number you could take out of everything, do that first. For example, we could divide this whole side by 2, and then we could take out the 2 from each of these because all these numbers are divisible by 2. We can also divide everything by pi because there's a pi in everything. Alright, look what happens. 0 divided by 2 pi is still just 0. And 2 pi divided by 2 pi is just 1, so we have r squared plus 12r minus 64. And we've got rid of all the pi's and we got rid of some of the 2's. And so now we have a much simpler equation. This is a quadratic equation. You can use the quadratic formula to solve this, or you could try and factor it. And we did factoring a while back. Hopefully you remember how to do that. I'm going to give you a chance to work that out on your own, give it your best shot, and then we'll put the answers up in a second. Okay, it turns out this is actually factorable. Maybe you guys remember the star method or the x method. We put the c term on top, it's negative 64. We took the b term on bottom, it's 12. And I need something that multiplies up to negative 64 and adds up to 12. I got 16 and negative 4. Therefore, my solutions, remember my solutions are the opposite of that. Again, a reminder of that is because when you factor this, you'd get r plus 16 times r minus 4 equals 0. And so you're trying to figure out what you could plug into here to get a 0. So if you plug in a 4, you'd get a 0. If you plug in a negative 16, you get a 0. So your solutions are negative 16 and positive 4. Well, negative 16 doesn't make any sense. Right? We can't have a radius of negative 16. But we can have a radius of 4. And so the answer is that the radius is 4 centimeters. All right, let's go on to the next page. Okay, almost done. I know this is a long video. We'll probably have to break it up a little bit. It says, the roof of a birdhouse is a regular hexagonal pyramid. The base of the pyramid has sides of 4 inches and a slant height is 12 inches. They don't tell us what to do here, so I'm going to say you're going to find the area of the sides. Okay, so find the area of the sides. I forgot to type it in. Alright, so we find the area of just the sides. Let's talk about what this shape looks like. It means you get to see some fabulous Mr. Roy drawings. They're the best. It looks something like a hexagon. That's the front, and then if I did the back, let's say I did the back in red, it would look something like this. So that's the part that you don't see. So all this is a pyramid. It's a pyramid with 6 sides and a hexagonal base. Now the hexagon base can be a little complicated to find out, but luckily they're not asking for that, right? I said just find the area of the sides. Well, that's just the lateral area. And if we go to the formula for a pyramid, Okay, I'll put it down over here. The surface area for a formula pyramid looks like this. T equals 1/2 perimeter times the slant height plus the area of the base. Well, they're saying in this problem that we don't care about the area of the base. So we only need this information. So that should be easy because we know what the slant height is and we know what the perimeter is. Well, we don't actually know the perimeter right away, but we can figure it out. If the sides are 4 inches and it's a hexagon base, that means that there's 6 sides. It's just 4 times 6. So T equals 1/2. The perimeter is 4 times 6, so that's 24. And the slant height is right here, the U2, it's 12. So that's a pretty easy problem, guys. Pretty straightforward. I do want to show you this real quick before I solve this. I want to show you where this formula came from. So if you were to unfold all of these sides, it would look like 6 triangles. It would look like this. 1, 2, 3, 4, 5, 6. Okay, well, each of these would be a little base, and they'd all have that slant height in there, right, which we call L. And so we could go and we could find the area of each individual triangle. It'd be 1/2 the base times that height, that slant height. Well, since we're just doing that over and over and over again, we could just add up all the bases, which we know is the perimeter of the hexagon. And so instead of having 1/2 base times slant height, we do 1/2 perimeter times the slant height, and it just automatically gives us the area of all the triangular sides. Kind of neat little shortcut. All right, let's back to this particular problem. We have 1/2 perimeter times the slant height. Well, half of 24 is 12. So I'm really just saying, what is 12 times 12? Well, we should know that one by heart. It's 144. And all my units were in inches. So this is just square inches. Boom. All right, that was a lot of math, a lot of formulas. But I think you guys can handle this stuff. It's just using the right formula for the right situation. Remember to take away bases if they don't need them. It says, for the summary, on the formula page there are a lot of new terms. Take some time to look at the pictures and determine what some of the new terms mean, especially the slant height in a pyramid and a cone. Write a definition for perimeter of the base, area of the base, and slant height in your own words. So I want you to define those 3 terms in your own words. And you also might need to think about what do we mean by base. I talked about that in the notes, but hopefully you can describe that back to me. And then in addition to that, don't forget to add in a question that you have. All right, I'll see you guys on the next video.